Let us talk about the stress-strain relationship in case of a wire. To observe what is the stress and strain relationship, we take a wire. At the end of the wire, there is an hanger, and that hanger supports the different weights for different stresses. The end point of the wire is connected to a pointer, and that pointer slides over a vernier scale that gives us the extensions or the strain. After that, when we put different weights, there are different elongations, and from that stress and strain calculations, we have got a curve, and that curve is called as stress-strain curve. When the stress is increased, the strain is increased in proportionality up to the point A. So this point A is called as point of proportional limit. When the stress is increased from A to point B, from A to B, the stress-strain relationship is not a straight line. But if the wire is unloaded at point B, it comes back to its original configuration via BAO. Now this point B is called as elastic limit. This region A to B, there is non-direct proportionality between the stress and the strain. If the stress is increased from B to C, the relationship between the stress and strain in the region B and C is not proportional. That means Hooke's law is not obeyed in this region. At point C, if the wire is unloaded, the wire doesn't come back to its original position via CBAO, it comes to its original position via CO dash. That means OO dash is a permanent set that is, or permanent elongation that is created in the wire. In this region B to C, it is partly elastic and partly plastic, or we can say that OO dash is plastic deformation. At point D, even if the wire is unloaded, the thinning of the wire takes place and the necks and constrictions are caused. Ultimately at point F, the wire breaks. The stress corresponding to the point F is called as breaking stress, and the F is called as the breaking point. Let us rewind a little. The region from O to A is called as the region of proportional limit. That means in this case the Hooke's law is obeyed. In the region A to B, the stress-strain relationship is not proportional, but in this region from A to B, if the wire is unloaded at point B, this point B is called as elastic limit. It comes back to its original configuration via BAO. After point B, if the stress is increased, the stress-strain relation between B and C is not proportional. If the wire is unloaded at point C, the wire comes back via CO dash, causing a permanent set or plastic deformation OO dash. This point C is called as yield point because at this point C, even if the stress is not increased, the wire begins to flow. So this point C is called as the yield point. At point D, even if the wire is unloaded, the thinning of the wire takes place and the necks and constrictions are caused. Ultimately at point F, the wire breaks. The stress corresponding to the point F is called as breaking stress, and the F is called as the breaking point. Thank you.